You'll be distracted. I said at 40. All right, here we go. Okay. I'll find your guys' as we're teaching. All right, you guys were doing these in the back of your spiral. What did you end up doing for number 114? What's the derivative? Rewrite. Right? Did you rewrite? Okay, power rule says to do what?
-1.
Bring down the 1/2, which will be 5/4. X to the... Have you guys gotten the negative 1/2 thing down? Kind of. On the other side, f prime of 3. 5/4. 3 to the negative 1/2? That's weird. When it says C, what's it just saying? Just solve, right? So if you want, you could replace the x with a c. You could replace an x with a c. Does our brain deal well with negative 1/2 powers? So let's go ahead and make it easier on our brain. So 5/4 square root of c equals 5/4 square root of 3. Uh-oh, what am I forgetting? Wasn't there something that it said the rate of change at c is twice its rate of change? Uh-oh, so what should have been here? 2. So what should be here?
2.
What's 2/4? 2/4 will be 1/2. My bad, right? 2 times, twice the rate of change. Does that make more sense? Cross multiply, anybody? 10 rad 3 going that away equals 20 rad c going that away. Uh-oh, now what? Right? 5 times 2 is 10 rad 3, and 5 times 4 is 20 rad c. Divide both sides by 10? Divide both sides by 20? Sure, we can do that. So divided by 20, divided by 20, we end up with 1/2 rad 3 equals rad c. And how do we solve for c? And we end up with 1/4 times, what's rad 3 squared? Why is this not killing a puppy?
It's not a binomial.
It's not a binomial. There's not a plus. So I'm allowed to distribute the squared. I'm not allowed to here. Poor puppy dies. But here I'm allowed to. Equals c. What does c equal? Oh my goodness, c equals c. Don't ever use that as a strategy on a test. Okay, questions on number 1, or number 114, or whatever, that one. Okay, number 2. How do we take a derivative?
Take it.
Take it. Would I rewrite anything? Would you rewrite anything?
6EX.
I would have the next piece. Did you?
Take out the pi.
Yeah, I could. Pi is a constant, 4 is a constant. That makes it a little bit easier, right? And I could say y prime or dy dx is equal to, uh-oh, it's the rough one.
6EX.
Ooh, I like him. Don't you? And what's the derivative of sine of x? Remember, constant multiple, that chills. Cosine x. Which one's that? Nice. Whoop. Got it. Sarah.
Why would you not make it a, why would you not make
Because the derivative of e to the x is unlike the derivative of x to the negative 1/2. This one, a number is in the power, a variable is down below. This one, a number is down below, a variable is in the power. The rule doesn't apply. Does that make sense? Now, if they said something like x to the a, it is a variable, but they probably say something like a is a constant, so then you're allowed to. But when the x is up there, all bets off. Leave it alone. Number 116, the last one. The position, of a particle is given by, nasty equation, where s is measured in meters and t is measured in seconds. The average velocity. What am I supposed to do? What's my formula? S of b. Who's b in this time interval? 2 pi. minus S of A, who's A in this time interval? All over 2 pi minus 0 is, Aw, struggle, and they don't have it in decimals, which means they didn't use their calculator. That's okay. 2 cosine of 2 pi plus sine of, am I deriving? No. What am I doing? Plugging in. 2 pi over pi plus 4 minus,
Should you find the derivative first?
why not? It asks for what kind of velocity. Now, if there wasn't the average, what are we allowed to do? Take the derivative. But since it said average, we're in trouble. So we have 2 cosine of 0 plus sine of 0 plus 0 over pi plus 4 all over 2 pi. Uh-oh, Trig, I hope we know it. What's cosine of 2 pi?
1.
1.
1. 1 times 2 is 2. What's sine of 2 pi?
0.
That's 0. So let's just use 0. What's 2 pi over pi? 2. Oh, plus 4. Oh, these numbers are nicer than I thought. Minus 2 times cosine of 0 is 2 again. Plus sine of 0 is 0 again. Plus 0 plus 4. I'm killing something. What am I killing?
Oh, it's cat. No. Seal.
Seal. If I don't distribute my negative, or if I don't put parentheses, am I right? No. I have to put parentheses, right? What's going to cancel out? A 2 with a 2 and a 4 with a 4. What's left? 2 over 2 pi. And what can I do with that? Reduce. Whew. Questions? How do we find rate of change, velocity? Listen to what I said. How do we find rate of change or velocity? Derivative of position of S of t. How do I find average rate of change or average velocity? Plug into the formula. Kiddos, before we do a quick little shortcut card in the sense of, hey, let's summarize things that we've seen. Let's go ahead and go on back to that example that we were trying to finish on Friday in your composition books. Put your spirals away. We're not going to check homework till tomorrow. That doesn't mean you don't have it ready necessarily. Some of you might. But let's just wait for everyone to catch up, okay? So let's go and get our notes out. Yeah. It's up to you. We only have 5 minutes anyway. If you just want to write down. Yeah. Okay. Question, and the letter A, why am I setting position equal to 0? Why am I setting height off the ground equal to 0? Because it says how long is it in the air, and it will stop being in the air once it hits the ground, and it's going to hit the ground when its height is 0, right? Where did I direct you on Friday, or how did I direct you on Friday to go ahead and solve this first problem? Use your calculator, right? And what were you supposed to solve for? The interval, the zeros, how about that? Define the interval or define the zeros. Did anybody keep going on this problem? Did anybody use their calculator? Alright, some of you are using it now. Go ahead and throw in your functions. Negative 16t squared plus 64t plus 80. Looking at those numbers, what are we going to have to watch out for? Our window, right? Aren't they kind of big? But if we were to go ahead and plug into negative 16x squared, I can't use t, remember. What was in my next variable? Plus 64x term plus 64t plus 80?
Yeah.
Times term. What's assumed that might work, and most of you would hope that it works? 6 is assumed standard, but seeing 80 and 64, I really don't know. Zoom Fit maybe, is that 0?
Yeah.
Let's see if that works. Hey, I see it. Do you see it? There's that 0. Let's go ahead and go find him. Second trace, remember we can find zeros. We can find x-intercepts using the calculator, the calculatrice, the calculator, this thingamabob. We can hit enter. You would not be asked to factor something this messy and gross on the AP. They would let you use your calculator. Hey, wait a minute, that's not 0. Question, what does scientific notation times 10 to the negative 11th mean? 0.000000. The calculator did the best it could. It's ultimately 0. And when is 0 happening? At 5. So therefore I can say, why didn't I find this 0?
Negative time.
That's negative time. That doesn't make sense. Wait, why at 0 is this thing starting up in the air?
Did you throw it up?
It's starting 80 feet up. Does that make sense? It's starting 80 feet up. So I can say, solving from my calculator, how long is it in the air? T equals 5 seconds. Okay, letter B. What is the velocity? Why am I not using S of B minus S of A all over B minus A? It's not saying average. So what am I doing? Taking the derivative. And I'm just saying V of some constant C is S prime of some constant C. Wait. What do I plug in? S of T. What is the velocity of the water balloon when it hits the ground? Well, first of all, who is S prime of T? I'm going to take away the C for a second. I just want to know who S prime is in general. Take the derivative. Negative plus, I guess I could, but what am I going to do anyway? Plug it in, plug it in. But I guess I could go ahead and pull out a negative 32 if you want to, and it'd be T minus 2 if you want to. But we just need basically velocity at 5 because it says when it hits the ground. And some of you, if I were to ask you what's the velocity when it hits the ground, you say it's 0 because you're like, it stops. It stops after it hits the ground. It hits with a velocity, which is the reason it goes splash or splat or whatever. 5 minus 2 is 3. 3 times 32 is negative. Negative? Why is it negative? Hold on. Units. Velocity is change in position over change in time. In this case, it's feet, which is our distance or our position per second. Why is it hitting with a negative? That's a high speed, right? Why is it hitting with a negative? Because it has a downward pushing motion or velocity. Angela.
What's the reasoning behind plugging the 5 into the T instead of 0?
Because it says when it hits the ground, and it doesn't hit the ground for 5 whole seconds. Remember, T is time, so I have to plug in time of 5 seconds. Does that make sense?
Yeah.
Okay.
So it's the time that it's in the air.
So through the time that it's in the air, or during the time that it's in the air, it picks up speed. So it gets thrown upward to 64, it peaks, aka there's actually a momentary stopping point before it goes negative speed down, and then with gravity it starts speeding up and then splash. Does that make sense? Okay, those are going to take just a second. I know it's 40, but I'm going to have time. We're just going to write down a couple hints that I wish I had given you on Friday. And this might help you in some of those word problems with some of the wording that you're going to see. Okay? For free-falling objects, a diver jumping off of a diving board, that's an example in the book, or a water balloon being dropped, or a baseball being dropped, or something being thrown up in the air and then it comes back down. For free-falling objects, if you see something like hit the ground, you take position and you set it equal to 0. If you see something like dropped, if it's dropped, not thrown, its initial velocity is going to equal 0. 0. Now, this could be seconds, this could be hours, feet per second, miles per hours, etc. Miles per hour. Just depends on the situation. This could be feet, this could be miles, I don't really know. But there's drop. Gravity for free-falling objects is your acceleration, which you might see in a formula that they try to give you, which is either negative 9.8 meters per second squared or negative 32 feet per second squared. Negative 9.8 meters per second squared or negative 32 feet per second squared. And besides that, the general equation, we'll stop here for today, of position for a free-falling object is the following. S of t is equal to 1/2 a sub naught t squared plus v sub naught t plus s sub naught. Where you have, for a free-falling object, gravity is your A, initial velocity is your v sub naught, and initial position is your s sub naught. Tomorrow at the beginning of class, we are going to go ahead and go over the evens to this section. We're going to cover in its entirety section 2-3 tomorrow. I'll want you to fully attempt homework for Wednesday on section 2-3, but it won't technically be due until Thursday. The next section, 2-4, is going to take us 3 days. We do have a test coming up next Tuesday or Wednesday, just depends. There's a lot packed into these sections, so it's okay to take a little more time on it. I'm going to go ahead and call out your names. Once again, guys, this is in no particular